I'm Professor Lucy Rogers, and Design Spark are really into innovation. And so I'm with Will Bolt talking about the WITT energy device. And I'm trying to think of all the different things that this could be used for. What good examples have you heard, Will?
There's a lot of stuff out in the sea. So people are trying to monitor things, a lot of environmental measures, things like temperature, turbidity, wildlife monitoring, even looking at what happens with coral reefs. And they'd love to be able to do that. But the problem is that actually getting power to those remote locations is actually quite difficult. They don't need a lot of power, but they need enough to actually give them power for their sensors. And actually accessing those areas is very difficult. So if you commission a boat to go out in the middle of the ocean, it's actually a very expensive thing to do. So what our device works like, it's a bit like a power socket in the ocean, if you like. So it just sits there generating its power from the marine currents, and it doesn't need a lot of marine current, actually. It can work at very, very low speeds. When we first looked at marine currents and, they're effectively what happens around the world, I thought, well, there's only going to be some areas where we're going to be able to generate power, but our marine architect sent us a map of all the currents that were above about 1 knot, and it's virtually everywhere, really. So it means that we can access a lot of areas of the world and be able to provide that that power socket, or knots to watts is a slightly cheesy way I described it before. So current knots. Sorry.
Very good.
I can't resist that sort of gag.
And it's they could just put it in and then forget about it, because it doesn't need so much servicing, and it's not like a battery that's going to run out. It's just going to keep going.
It's just going to keep going, exactly. And so the intention is that it should be, it will be very reliable. We should be able to make this thing so that it will last, at least 10 years worth of life.
Wow, yeah.
As long as we can seal it and the seawater doesn't get in, which we know we can do, and as long as we can design the gears and the bearings to be able to last. This gearbox is, it's under a lot less strain than, say, an automotive gearbox or a bicycle gearbox that I've got on my bike. So, we will be able to design this to last a very long time. And the electronics is pretty well proven, and a generator is pretty well proven. So we know we can make this thing last a long time without servicing.
So it's a fit and forget thing. So now you're curious as to what the Design Spark community can come up with, what great ideas that they can think of that they could use this device for.
I'd love to know what people are thinking. When we speak to people, they always come up with different ideas. They always say, oh, you could use it for this, you could use it for that. And sometimes they're a bit wacky, but other times you think, oh, that's a great idea. And I know that the Design Spark community will be looking at this and thinking, I wonder if they've thought about, and that I'd love to know that. I wonder what they thought about, because we may not have done, and I'd love to hear that. And it's fascinating from our point of view. Actually hearing those potential applications, that's what makes us tick or swing like a pendulum. That's exactly it. We'd love to know what people are thinking.
Brilliant.
And work on that. Absolutely.
Design Spark community, it's over to you.
Yes, please.